For this video, we're going to be drawing the Lewis structure of small molecules. So as mentioned in the previous video, the main idea of chemical bonding is that atoms combine in order to achieve a more stable electron configuration. And an atom is most stable when it has the same number of valence electrons as a noble gas, which is 8, or 2 in the case of helium. For more information on this, check out the previous video titled How to Draw the Lewis Structure for Atoms. In this video, we will be focusing on drawing Lewis structures for small molecules. We'll learn later on that drawing Lewis structures for large molecules is rather cumbersome, so we switched to bond line structures. But more on this in the coming videos. So now, to achieve a noble gas configuration, atoms tend to bond in two ways. Atoms will either form ionic bonds or covalent bonds. In ionic bonds, simply put, electrons are transferred between atoms, whereas in a covalent bond, electrons are shared. This video will focus mainly, or rather solely, on covalent bonds. So when it comes to drawing the Lewis structure for small molecules, we can follow 4 general steps. Let's use an example molecule, formaldehyde, which is CH2O. That's the chemical formula to illustrate this. So now, step 1 is to determine the number of valence electrons for each atom. So to do this, let's draw the Lewis structure for each individual atom. So again, if you need some more help with this step, check out my previous video called Drawing the Lewis Structure for Small Atoms, or just atoms. So for carbon, we have first we draw the symbol, then we fill in each side with electrons, corresponding to its group number, which in this case is 4, one side at a time, 1 electron at a time. And then for the 2 hydrogens, we have H, the symbol for hydrogen, with 1 electron, and another hydrogen with the symbol H with 1 electron, because it's in group 1 of the periodic table of the elements. And then we have oxygen. In this case, we draw 6 electrons, one side at a time, 1 electron at a time. And for oxygen, we have 6 electrons because oxygen is in group 6. So in total, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 electrons in total. So we have to account for 12 valence electrons in our diagram. If the compound is ionic, the number of electrons will change depending on if it's an anion or a cation. So now let's move on to step 2. So in step 2, we want to connect any atoms that form more than 1 bond. So, and also we want to save the hydrogens for last, since they're only capable of forming 1 bond. So in this case, we will connect the oxygen and the carbon atoms because they're able to form 2 and 4 bonds respectively. So we draw the carbon Lewis structure and the oxygen Lewis structure. But in this case, we draw two electrons in between, and then we fill out the rest of the Lewis structures. So just like this. So as you can see, oxygen shares one of its electrons with carbon, and carbon shares one of its own electrons with oxygen. And each atom helps the other atom to achieve its goal of an octet. So for step 3, we connect the hydrogen atoms. As a rule of thumb, we want to connect the hydrogens to the atom with more unpaired electrons, or in other words, more empty spaces. So between the two, we're going to connect the hydrogen to the carbon because carbon has 3 unpaired electrons, whereas oxygen only has 1. So we draw 2 more hydrogens on top or next to the hydrogen, doesn't matter where. Sorry, I mean the carbon. And it doesn't really matter where you connect the hydrogens to, right? So let's draw the 1 hydrogen here. And then let's draw another hydrogen down here. So as you can see, the carbon atom helps the hydrogens to achieve its noble gas configuration of helium, which we call a duet. Now, since the octet is not satisfied for oxygen or carbon, because each atom only has 7 electrons around it, 7 electrons each. So how would we satisfy their octets in this case? Remember, we are already out of electrons, since we're only allowed 12 in total, right? We can't just magically add electrons to our molecule because it's not an anion, right? It's not a negatively charged ionic compound. So what can we do? And this brings us to step 4. And for step 4, we want to pair any unpaired electrons so that each atom achieves an octet using either double or triple bonds. So in this case, we bring the 2 remaining electrons on the carbon and the oxygen down next to each other. So we just bring these electrons over to form a double bond. So in this case, our new Lewis structure will look something like this. We have our carbon, our hydrogens, and we have a double bond between oxygen and carbon. So for a double bond, for our double bond between carbon and oxygen, 4 electrons are being shared between them instead of 2. So now each atom in the molecule is completely satisfied without going over our electron total of 12. So finally, we can use some shorthand by drawing single bonds with a single line, and double bonds and triple bonds with two lines and three lines respectively. So we can redraw our formaldehyde molecule like this. So wherever you see a single bond, replace it with a single line, and wherever you see a double bond, replace it with a double line, and wherever you see a triple bond, replace it with three lines. In this case, we don't have any triple bonds, so we will leave that alone. So we take our carbon hydrogen bond or bonds, and we draw single lines between them, and then we take our carbon oxygen double bond, and then we draw two lines between them, and then we fill in the remaining unpaired oxygen electrons. So that's going to be it. With that being said, thank you for watching. Have a nice day.